Hi everybody. Today we are discussing about very important part under physics. Actually we need to study about mechanics. But before we study mechanics, it is compulsory to know about vectors, right? And here I will explain the things that we should know about vectors. Now here our basic topic become vectors. Now think about the definition of a vector. Normally we consider a vector as a physical quantity which has a magnitude and a direction. The genuine definition is given by a mathematical entity which has a magnitude and a direction, right? But normally we consider that one as a physical quantity which has a magnitude and a direction. And also think about scalars. Normally we consider a scalar as a physical quantity which has a magnitude but it doesn't exist a direction. Right? Now here I will use some examples about vectors and scalars. And here I am taking in this side I am taking vectors. And here scalars. Now a famous vector is a displacement. We can take the displacement as the vector, but the distance becomes a scale. And also we know how to take the velocity. We take the velocity as displacement divided by time, and so that it becomes a vector. Here I am writing the second one and it becomes velocity, but speed becomes a scale. And also think about the acceleration. It becomes a vector, and also I can take the time as a scalar. We know that time has only a magnitude and it doesn't exist a direction, right? And also another famous vector is force. But we can consider as a scalar a quantity forms under the force. That one is the pressure. Pressure becomes a scalar. Pressure is taken by force divided by area. Force is a vector, but we are dividing it by area. Area becomes a scalar, and I am having a scalar. That one is pressure, right? And also think about momentum. It becomes a vector, and I can take another one for a scalar. This one is energy. We know that there are several types of energies: mechanical energy, nuclear energy, and thermal energy, like the light energy, right? There are different variations of energy, right? Energy is clearly a scalar. That means it has only a direction, it has only a magnitude, not direction, right? And I am writing another one. This one is EMF. EMF means electromotive force. Electromotive force is a vector. We know that if you are selecting a cell, then it has an electromotive force. Clearly, it's supposed to push electrons towards your selected direction, and that's why electromotive force become a vector. And think about electric charge. Electric charge become a scale, right? I will give some other examples for vectors and scalars. another one I'm taking here. That one is magnetic flux. This one is a vector. Now I'm taking scalar set here. Magnetic flux become a vector. I can take a scalar as gravitational potential. And also I can take electric field intensity. And also I will take electric potential as a scalar. Now here we are having magnitude and a direction for the quantities that I wrote at the left side, and the quantities that I wrote at the right side are having only a magnitude, right? This one is the basic difference between a vector and a scalar. Now here I will give a simple example for vectors and scalar. Now think that an object moves to the right side and think it travels a distance 4 meters, and think that then it travels directly upward. That means this angle becomes a right angle. It directly moves upward a distance 3 meters, and here the total distance, travel distance, become 7 meters. 4 plus 3 becomes 7 meters. Now think about the displacement. If you need to take the displacement here, it is compulsory to join the starting point and the ending point, and you will take the displacement like this. Now if you need to take the displacement, then it becomes 5 meters. This length is taken by using Pythagoras theorem. You know how to apply the Pythagoras theorem. Now here I will write it at here. S equals 4 squared plus 3 squared square root. It becomes 5 meters. Don't forget that since the displacement becomes a vector, we have to find its direction. I am taking this angle as theta, and here tan theta become equal to 3 divided by 4, and so that theta become equal to tan inverse 3 divided by 4. This is the way that we have to find a vector, but for scalar we only consider the magnitude. But here you can see that we have found the direction of the displacement, right? I think now you are having a clear idea about a vector and a scalar, right? Now here I will give the representation of a vector in the next part. Now I will start that one. Now think that a vehicle moves from point A to point B. You can see that here I have selected it as directly moved from A to B. Now here if I need to represent the displacement, then I can use the letter S and apply an arrowhead over it. Now here this displacement become a vector. You can see that I have applied an arrowhead or the letter S. Otherwise, I can apply a line below this letter S. Actually, I have underlined this one. Sometimes we apply this in a curly way like this, right? And also another type is that we can write the letter as a bold letter like this. I think this one is wasting much more time, and if you like to waste some time, then you can bold the letters like this, right? I think it will be more better to apply a vector like this. Don't try to bold it. You are wasting a time lot, huh? Right? Right. Now, so that here I have used a single letter to represent this displacement S, and if you like to represent it by using these two letters A and B, then you can do it. Now here the displacement vector become AB vector. Now you can see that the object has been travelled starting from A and ending from B. Now you can see that I have written AB and the arrowhead is applied from A to B. That means the object moves from A to B. Right. Now I think you know how to represent a vector. And in the next part I will explain that what are the conditions that two vectors should satisfy to become equal together. Now here I am taking two vectors. One is a displacement. I am taking a displacement. This one is think about as 5 meters. And I am taking another vector. That one is a force, and I am taking this force as 10 newtons. Now here I am trying to give you 4 conditions that these two vectors should satisfy if they become equal together, right? Now clearly you know that this one become a displacement. It is measured by meters, but here the force become another vector. It is measured by newtons. Clearly these are different quantities, right? That means actually they are not in the same type. So that the number one requirement is that both vectors should be in the same type. Right, okay. Now I am taking this one as a force. 5 newtons. Now here, clearly you know that these are in the same type, but the magnitudes are not equal. So that the second sufficient condition is that these two vectors should be in the same magnitude. But here you can see that these are the same magnitude, but they are not equal together. Why? The reason that they are not parallel. So that the third sufficient condition is that should be parallel. The vectors should be parallel to each other. Now I am here taking parallel vectors. Okay, the same type, here the same type, and the magnitudes are in the same, and also they become parallel, but these two are not in equal vectors, because here you can see that these are not directed to the same side or the same direction. So that the fourth condition is that should be directed to the same direction. If two vectors are satisfying these four conditions, then clearly we consider that they are equal vectors, right? Normally, we are having equal vectors under physics, and we can learn them in the future parts, right? And so that now here I have written four conditions to satisfy as two vectors become equal together. Same type, same magnitude, and the two vectors should be parallel to each other, and they should be directed in the same direction, right? These are the four conditions. Now in the next part I will explain that how to change the direction of a vector. Now think about this vector AB become a vector. Now think that a person travels from A to B. I can change its motion from B to A. How? Now look at time here, change the direction from B to A. Simply I can do it. Here only I need to apply a negative sign in front of this vector. If I am changing the direction of a vector, it is compulsory to apply a negative sign in front of it. I can give the proof of this relation. Now here B vector become equal to minus BA vector. Now I will give the proof. I think this space is enough to give the proof of this one. Now here this one becomes the proof. I am taking the vector AB, and here is given that this vector AB become equal to minus BA vector. Now here I am taking the same relation that has been given here and think about the BA vector. According to this regulation, it is mentioned that if we need to change the direction of a vector, then it is compulsory to apply a negative sign in front of this vector. Now I will do the same thing here. I am writing the vector BA as negative into AB vector. What will happen? Negative into negative, it becomes positive. So that here AB vector become equal to AB vector. That means if you need to change the direction of a vector, always you have to apply a negative sign in front of the vector. Now think that an object moves towards south with velocity 5 meters per second. Clearly velocity become a vector. Now if you need to change its motion towards north, then you can do it. If you are changing its direction towards north, it becomes negative 5 meters per second. And think that a force exerts on a particle to the left side as 10 newtons. Now you can change its direction to the right side by applying a negative sign in front of it. This one becomes negative 10 newtons. Now I think you are having the idea that how we can change the direction of a vector, right? Now here you have learned about several things. One is you have taken an idea about a vector and a scalar and how to represent a vector, and next how to change the direction of a vector. And in the next part you will know how to solve a vector diagram. Actually we need to know about how to find a resultant vector. Normally a resultant vector is known as a vector which applies instead of a system of vectors. That means, as an example, we consider about a system of forces. We can apply a single force instead of that system. We will learn how to do it, right? Now think that here you are having several vectors. I am taking them as A1, A2, A3, and finally it become AN. There are n number of vectors here. Now here my target is to find a single vector instead of this system. I can take it as the vector capital R. Now here, basically you should know about several things here. The first one is that you should know about the vector triangle. Vector triangle. I will explain how that we can take the vector triangle. Now here think that two vectors are exerting at a point. I am taking them as A1 vector and next it has A2 vector. There are two vectors here, A1 vector and A2 vector. Now here I can sketch a triangle by using these two vectors like this. Here I represent the vector A1 according to its magnitude and direction by using a line which is arranged according to the selective ratio, and you can see that here this line is parallel to this line, and next I am taking the same ratio and represent the vector A2 at here. Now here, if I can complete a triangle, then I will take the resultant vector capital R. Now here, vector capital R become equal to A1 vector plus A2 vector. Sometimes we draw a triangle like this. This one AB vector and this one BC vector. Here the resultant is given by the vector AC. That means AC vector become equal to AB vector plus BC vector. Now here I will give a simple example to find the resultant vector, and I am taking two forces which are perpendicular to each other. Look at here, I am erasing this part and I will give the example for you. Now think that two forces, 12 newtons, and 5 newtons are exerting at a point like this. Now here I am trying to draw a vector triangle according to the magnitudes and the direction of these vectors, otherwise these forces. Now here I am representing the force 12 newtons by a line segment like this, and later the force 5 newtons. Now again you can apply the Pythagoras theorem to find the resultant vector, capital R. I am taking it as capital R. I am taking its magnitude. Here normally if I am representing in magnitudes, I can apply a mod sign like this. Now here resultant vector become capital R, and if I am applying the mod sign here, I am taking the magnitude of this resultant vector. It become 5 squared plus 12 squared square root. It become 13 newtons. Now think about direction here. Tan theta. Again tan theta become equal to 5 divided by 12, and theta become equal to tan inverse 5 divided by 12. This one is the direction of the resultant vector. Right? And so that don't misunderstand this one. Sometimes you may take the summation as 12 plus 5, it becomes 17. That one is incorrect. Clearly it is compulsory to consider the direction of the resultant vector. That's why we are having its magnitude as 30 newtons. Now in the next part I will draw some vector diagrams, and I will explain how to find the resultant vector. Now think you are having a vector diagram, and here AB vector, and next BC vector, and finally CA vector. Now here you need to find a resultant vector instead of this vector diagram. This one is a very simple diagram, and here if you need to take the vector capital R, then you can write all the vectors that exist in this diagram. AB vector plus BC vector, and finally it becomes CA vector. And here AB vector plus BC vector, I gave that AB vector plus BC vector become equal to AC vector. I gave it previously. This one become AC vector. AC vector plus CA vector. Now here I have given that if you need to change the direction of a vector, you have to apply negative sign in front of it. Now here I am applying a negative sign, and I will write this one as AC vector. Now I have converted the CA vector into AC vector by applying a negative sign. Now here you will have AC vector minus AC vector. Now here this one become 0. But don't forget, this one is a vector. We are taking it as the null vector. This one is null vector. Null vector. So that here the main thing you can see that here this vector diagram is an enclosed one. You can see it. This one is an enclosed one. If the vector diagram become an enclosed one, don't forget that the resultant vector become 0. Always, if we are having a set of vector diagrams, then there are several parts which are enclosed, then you can take the resultant of them as 0. Clearly it should be an enclosed one. Don't forget it. Now here you know how to solve an enclosed vector diagram. This one is an enclosed vector diagram, and the resultant become null vector. I will draw another diagram here. I am using common letters, and it will be more easier for you. Right, now here there are 3 vectors. The first one is the vector, and next BC vector, and next AC vector. Now here AB vector plus BC vector, we have taken it as AC vector, and so that you know that clearly the resultant vector become 2AC vector. This one is the answer. a very simple vector diagram. 2AC, the result become 2AC. Right? If you need to take an idea about this one, you can take a very small insect and think about its moving path. Now think that you are releasing this insect at capital A, and this insect moves to B and next to Z. Now you can see that it has traveled from A to Z. And again, don't forget that this insect travels directly from A to Z in another way. That means it has been traveled 2 times from A to Z. So that the total summation of the vectors become 2 times as AC vector. This one is the resultant vector. Now here I am giving another one. Now here I need to take the resultant of this vector diagram. There are 6 vectors in this diagram. Now you can see that BA vector, AC vector, CD vector, and CE vector, and ED vector, and DC vector. Now look at this diagram. Clearly I have given an important thing in the previous part. I gave that if a vector diagram becomes an enclosed one, then the resultant becomes 0. And here you can see that this vector diagram become an enclosed one. You can see that you can start from B and travels to A and again to B. The resultant of this part becomes 0. Similarly, the resultant of this vector diagram also becomes 0. And so that here the resultant becomes the null vector. This one is very simple. And next I will explain about another diagram. And think that I am having a vector diagram like this. Now this one is my next vector diagram. I need to find the resultant vector for this system of vectors. Now here, according to this diagram, are there enclosed parts in this diagram? Check carefully. No, we are not having enclosed vector diagrams or parts at here. And so that, take your insect and keep it at a suitable point to start its motion. Now here I am keeping the insect at capital A. Now here you can see that it travels to B and to C and to D and again to E and to F, and finally it travels to G. And so that our insect has been traveled from A to G along this large path. And so that if I am taking the resultant vector, first I am having a vector AG, and don't forget another part we have to consider here. Look at here, the insect travels from A to Z and Z to E and E to G. And again I am having another vector AG. Look at the path again, A to C, C to E, E to G. and so that I am having another AG. And don't forget, at the beginning, another AG vector exists. You can see that is arrowhead. So that I have to apply another AG vector. Now the total become 3 times as AG vector. This was the resultant vector that we can apply instead of the system of vectors. Right. Now I will give another one. This one is actually relatively different than the others, and I am taking a common hexagon which the side lengths become equal, and now think that you have given this hexagon with equal sides A, B, C, D, E, F. Now think that you are having vectors A, B, B, C, D, E and F vectors. Now here you have given the vectors A, B vector, B, C vector, D, E vector and F vector. These are the vectors you are having here. I told that the side lengths become equal here. Now here you are having to find the resultant vector instead of this system. Now how you can find the resultant vector? Are you able to travel like this? A, F? No, here we are not having a vector at F, right? Now how that we can solve this one? Think. Now we need to find the resultant vector. We are having 4 vectors here. Now here this one become a common hexagon which the side lengths become equal. Here you can cancel this vector F at here and you can place it on CD. Look at here, I am erasing this vector and I am applying it at here. That means I am replacing this side CD by the vector F. And here think about the type of the vector has to be changed. And the magnitude, here the same magnitude. And also become parallel. And directions are also the same. And so that if I am applying the vector F at here, it doesn't change or it doesn't give any effect on this vector diagram or the system of vectors. Now simply you can find the resultant vector at here. AB vector, BC vector, CD vector and DE vector. Now here you can see that this one becomes the resultant vector. Clearly, this one become R become equal to AE vector. So that simply we can find the resultant vector if we are having an idea that we can place this vector F on CD. So that this one become an easy solution for this vector diagram. And later I will explain how to take the vector subtraction and the vector addition. Now think that you are having two vectors at a point. I'm taking them as P and Q, right? I'm taking the angle between these two vectors as theta, and I can sketch a parallelogram according to their magnitudes and directions. Now here this one becomes the vector P, and here the vector Q. Here this angle becomes theta. Now you can see that the diagonal gives the resultant of these two. R vector becomes the summation of the vector P and Q. This one is very easy. This one is very easy. R vector becomes equal to P plus Q. Now actually we are having a theorem under forces. This one is actually known as parallelogram theorem of forces. And here we will learn about parallelogram theorem of forces under mechanics, and later you can know it, what is meant by parallelogram theorem of forces. That means here actually if we need to take the vector summation, it is compulsory to sketch a triangle by using these two vectors. This one is a parallelogram, but here think that I am erasing these parts. What will happen? Clearly, you will take the vector triangle. That means actually the parallelogram theorem of forces that I am trying to explain in the future sessions will be taken by this vector triangle actually. And here I need to take the vector subtraction. Now as an example, think that I am taking two forces. Now think that I am taking two forces, F1 force and F2 force with an elevation theta, and think that they are having the same magnitude. The same magnitude. I told earlier that we are applying the mod sign to take the magnitude of that vector. Now think that these are having the same magnitude, capital F. Now think that you should find F1 vector minus F2 vector. How that you can find F1 vector minus F2 vector? Now this one is the problem. Think. If you need to find F1 vector plus F2 vector, I know that means if you need to take the vector summation, then clearly you will take it by using a triangle. You can use the same procedure to find the vector subtraction. Now look at here. I am drawing these two vectors, F1 vector and F2 vector, like this. The elevation becomes theta here, right? And I am taking the line segments as AB and AC. Now here I have drawn these lines according to the magnitude and the direction of these two F1 and F2 vectors. And think that here I am introducing a third vector. I am taking it as CB vector. You can see it, this one becomes CB vector. I am introducing it, right? Now think about the vector triangle. Here AC vector plus CB vector become equal to AB vector. Look at the vector diagram. AC vector plus CB vector become equal to AB vector. Right? The problem is to find vector F1 minus vector F2. This one is a problem. Right? Now here, that means you are trying to take the vector subtraction. I mentioned it earlier. And here you can see that CB vector become equal to AB vector minus AC vector. Now here AB vector become F1 vector and AC vector become F2 vector. Now here if you need to take the subtraction between these two, here I am taking the subtraction of this set F1 minus F2 mod sign, right? And here you can see that if I need to take the vector F1 minus vector F2 and its magnitude, then you can see that it can be taken by the magnitude of the vector CB. If I am applying the mod sign here, then I have to apply the mod sign for the CB vector also. And so that my main target is to find the side length of this triangle for BC. This angle become theta, and both are having the same magnitude, capital F. I need to find this side length BC, and here if I am drawing a perpendicular starting from capital A, and you can see it here, it equally divides this line segment, and this angle becomes theta divided by 2. Now think about this side length, what will happen? If you are taking the small part, it becomes F sine theta divided by 2. Simply you can take it by using sine. So that here CB become equal to 2F sine theta divided by 2. This one is the magnitude that we need here. So that F1 vector minus F2 vector, and if I am taking its magnitude, it becomes 2F sine theta divided by 2. This one is the final answer. So that here we had two vectors F1 and F2 with the same magnitude, capital F, and the problem that we had here to find the magnitude of the difference between these two vectors. And here I told that first we need to sketch a vector triangle, and we introduce a third vector CB here. By the vector CB, we took the difference between the vectors F1 and F2, and finally we took its magnitude. So that you have to apply a small geometrical part here to take the subtraction between two vectors and its magnitude. This one is the way that you have to follow. And I will explain another question to how to find the vector subtraction or the vector difference. And think this one is given in a new way by joining a nice question under circular motion. Now think that a particle rotates around a circular path like this. Now think here, this one moves with constant speed v, this circular path, and here the rotated angle becomes 60 degrees. Now think that you need to find the change in the velocity. Actually, the change in the velocity is equal to a vector difference, right? Now here simply I can find the solution by selecting the vector components here. Now here, look at here. Now here this one become right angle, and again this one become right angle, right? Now here this angle become 30 degrees, and here again this one become 30 degrees. Now here this angle become 60 degrees, and that's why it become 30 degrees actually there. And so that I am taking the components of the vector v. Here it become v cos 30, and here it become v sin 30. And again here it become v cos 30, and here again v sin 30 degrees. This angle become 30 degrees because this one become 30 degrees. And so that think about the vector difference. And if you are taking the difference or the change, then think about the vertical components for the velocity. V cos 30 and again v cos 30. I am taking the difference. Both components are towards upward direction. So that here I am taking two vector subtractions along vertical direction and along horizontal direction. I can take it as delta v y along the vertical direction, and it becomes 0. So that you can see that if I am taking the difference of the velocity towards vertical direction, it becomes 0. But think about delta vx. That means I am taking the vector subtraction or the vector difference or the velocity difference along the x-axis. Now here you can see that at half situation the velocity to the left side it becomes v sin 30. Minus v sin 30. This one is to the left side, this one is to the right side. Now I told that if you need to take or if you need to change the direction of a vector, then you can change its sign. That means here I can change this negative sign into a positive sign, or otherwise apply a negative sign in front of this v, and I have changed the direction. It becomes towards the left side 2v sin 30 degrees. You know that sin 30 become half, and so that I am having the magnitude v, and the direction will be to the left side, so that the vector subtraction towards the left side it become v. Otherwise, the change the velocity towards to the direction or parallel to the direction of x-axis become towards the left, it become v. And so that this is the way that we can take the vector subtraction or a change in the velocity, right? And in the next part I will explain about the motion for the objects.